In this session, I'm going to cover how to use decision table to describe the decision logic. We have learned how to draw data flow diagram, and here is an example of a data flow diagram. It describes the information flow in this order system. So based on the order submitted by customer, this system makes a decision. That is, it either rejects the order, or it accepts the order. So here a decision is involved, but this data flow diagram doesn't describe the decision logic. That is, it doesn't show under what conditions an order is accepted or rejected. Instead, it focuses on describing the information needed and the information generated in this decision process. However, this decision logic is really important because programmers need to understand users' decision logic to develop the system. Then what tools can we use to describe decision logic? So there are three tools. We have structured English, decision table, and a decision tree. In this session, we just focus on decision table. First of all, a decision table is a matrix that shows decision logic. That is, it shows under what conditions we take a specific action. Action here could be, for example, to accept an order or to reject an order. Compared with decision tree or structured English, decision table is extremely powerful and useful when we need to describe very complicated decision logic that involves lots of conditions. This figure shows the general structure of a decision table. On the left-hand side, the upper part shows the conditions involved in the decision, and the lower part lists different actions we may take after we make our decisions. And the right-hand side has different rules. Each rule is about under what conditions we take what actions. This shows an example of decision table. It shows the decision made regarding weekly payment for workers. We have this condition part. There are two conditions. The first one is regarding the type of worker. And there are two types of workers. So this S stands for salaried worker. And this H stands for hourly worker. The second condition is regarding how many hours the worker worked during a week. And then we have four actions here. The four actions are the possible outcomes of decisions regarding payments. On the right-hand side, there are four rules. The first rule says, if the worker is a salaried worker, then just pay her base salary. The second rule says, if the worker is an hourly worker and she worked less than 40 hours, then we make a payment based on her hourly rate. And also, we add a record in her absence report. The third rule says, for an hourly worker, if she worked exactly 40 hours, then we just pay just based on hourly rate. And finally, this rule says, again, if this worker is an hourly worker and this worker worked more than 40 hours, then we take two actions. The first one is, again, pay based on hourly rate. And the second action is, we need to calculate overtime. So as you can see here, we have four rules. And each rule is about a specific action or a specific combination of actions we need to take under certain condition. To create a decision table, we need to take 4 steps. In step 1, we figure out the conditions involved in the decision process and the possible values for each condition. For example, if a decision is based on whether a customer made a payment using a gift card, then using gift card is a condition. Because it is a binary condition, its value is either yes or no. There are two possible values. On the other hand, suppose account balance is a condition, and based on whether account balance is less than $1,000 or between $1,000 and $10,000 or above $10,000, we have three different decisions. Then this condition has three different values. In other words, based on this condition, we can classify people into three groups, and then for each group, we may take different actions. In step 2, we put down all possible actions we may take. Then we list all possible rules to get the initial version of our decision table. Finally, we remove redundancy to simplify the decision table. So here we have 4 steps to take to create a decision table. And we have 2 examples here to illustrate the process to create a decision table. In the first example, we want to describe a decision which is about whether to accept or reject an order. The decision is just like this. If the product order is in stock and the customer has good credit, here, both should be satisfied. Then the order is accepted and fulfilled. On the other hand, this credit requirement could be waived by the credit manager. So which means if product is in stock and the buyer doesn't have good credit, but the credit manager waived the credit requirement, still the order is accepted. Finally, any other orders would be rejected. We follow the process to create the decision table. First of all, we list the conditions involved. And here we have 3 different conditions. The first one is about whether the product is in stock. And it has just 2 possible values, either in stock or out of stock. So here, either yes or no. The second condition is whether the customer has good credit. Again, there are 2 possibilities, either yes or no. The last one is whether there is a waiver from the credit manager. Again, yes or no. In the second step, we put down the actions. So there are 2 possible actions. Either we accept the order or we reject the order. In step 3, we list all possible values. This step is very important because, we don't want to miss any rules or duplicate any rules. We needed to have exactly the same number of rules as needed. That is not difficult because the number of rules is just the multiplications of the numbers of values of those conditions. So in our example, we have 3 conditions, and each condition is binary, either yes or no. So each condition has 2 possible values. We just multiply the numbers of values of our conditions. In this case, it is 2 multiplied by 2 multiplied by 2. That is, we have 8 rules. So then we come up with this table. So this table right now is not finished yet. It only has our conditions, and also there are 8 columns, and each column is associated with a rule. Then we start with our first condition. So this condition is about whether the product is in stock. As this condition has 2 different values, we divide the 8 columns here into 2 parts. That is, the first 4 columns are in part 1, and the next 4 columns are in part 2. Part 1 is associated with the cases in which the product is in stock. As you can see here, we have yes, meaning the product is in stock. And then in part 2, the product is not in stock. Then we just look at the second condition. So the second condition is about whether the customer has good credit. It again has two possible values. So remember, we have divided the whole table into part 1 and part 2. And here for each part, just based on the second condition, because it has two possible values, we divide each part into two subparts. So here part 1 is divided into two subparts, part 1a and part 1b. Each part in this case would have two columns. And also from one subpart to the next subpart, the condition for this specific condition needs to change its values. So which means in part 1a, the customer has good credit. And then in part 1b, we need to switch the value. And that is the customer doesn't have good credit. And similarly, part 2 is divided into two subparts, part 2a and part 2b. And again, from part 2a to part 2b, the answer to whether the customer has good credit is switched from yes to no. We have one more condition to handle. So as you can see, now this table has 4 parts. Right? So then the last condition is whether there is a waiver from the credit manager. Again, it has two possible values, either yes or no. But then we just divide each of the 4 parts into two subparts. Each subpart will be just one column, so as you can see. And again, just as what we have done, from one subpart to the next subpart, and in this case, from one column to the next column, we need to change value. So that is, we have yes, no, so on and so forth. So then we list all possible rules. In this case, we add the actions part to this decision table. So we have accept the order, reject the order. And then based on the information we have collected, we finish this decision table. So here we have in total 8 rules. Rule 1 says if the product is in stock and the customer has good credit, and also there's a waiver from the manager, then we accept the order. Rule 2 says the product is in stock, the customer has good credit. There's no waiver from the manager, then again, accept the order. The third rule says the product is in stock, the customer doesn't have good credit, but there is a waiver from the manager, then again, the order is accepted, and so on and so forth. In the last step, we'll try to simplify our table. Right now, there are 8 rules, but some of them could be merged to make the table simpler and easier to understand. We look at the first 2 rules here. So they share the same action. That is, in both rules, the order is accepted. On the other hand, they also share some of the conditions. That is, in both rules, the product is in stock and the customer has good credit. The only difference is the last condition. So that is, here in rule 1, there's a waiver from the manager. In rule 2, there is no waiver from the manager. So that is the only difference. But here it is clear that this only difference doesn't matter, as the decision is the same. The order is accepted. So we could merge the 2 rules into one. We just need to say, as long as the product is in stock and the customer has good credit, then we accept the order. And also, if we look at the last 4 rules, again, they share the same action. The order is rejected. And also, they share one thing in common. That is, if we look at the first condition, the product is not in stock. So here, it's very clear. As long as the product is out of stock, then whether the customer has good credit doesn't matter. Whether the manager waived the credit requirement doesn't matter. So the decision is always to reject the order. Then we can merge the last 4 rules into one rule saying if the product is not in stock, then we just reject the order. Here is our final version of the decision table. And as you can see, we have simplified the decision table. Initially, we have 8 rules, but right now we only have 4 rules. So the first rule says if the product is in stock and the customer has good credit, then we just accept the order. So here, this dash means, this condition doesn't matter. Second rule says if the product is in stock and the customer doesn't have good credit, but there is a waiver from the manager, then we accept the order. And then the third rule says if the product is in stock and the customer doesn't have good credit, and also there is no waiver from the manager, then we reject the order. And the last rule says if the product is not in stock, then we reject this order. And then we can present this decision table to programmers who then would develop the system. The second example is about giving different customers different coupons or discounts based on different conditions. So here it says, here a customer who orders $1,000 or more would receive a 10% discount. And then a customer who orders between $500 and $1,000 would receive a 5% discount. A customer who orders less than $500 but pays using our charge card would receive a $25 coupon. Finally, all other customers will receive a $5 coupon. There are 2 conditions here. The first condition is regarding the order amount, how much money the customer pays. So we can divide this order amount into 3 different ranges. That is, less than $500, between $500 and $1,000, and also above $1,000. So here we have 3 different ranges. And then we can simplify the notation here. So we can use this L to represent the lower range, which is less than 500, and this M to represent the medium range, which is between 500 and 1,000. And finally, this H to represent the high range, which is above $1,000. And the second condition is regarding whether the customer pays using our charge card. So here, there are 2 possible values, either yes or no. And based on the 2 conditions and their possible values, and then we can figure out, here we have actually in total 3 multiplied by 2, we have 6 rules. And also there are 4 different actions, 10% discount, 5% discount, $25 coupon, and a $5 coupon. Then we start to organize our rules. Because we have 6 rules here, so we have 6 columns in our table. We look at the first condition. So the first condition has 3 different possible values. We have a low, medium, and high. And we can divide the 6 columns into 3 parts. Each part has 2 columns. So we can come up with this layout here. And then we look at the second condition, which is about whether the customer makes payment using our charge card. It is either yes or no. So there are 2 possible values. Then for each of the 3 parts, we divide it into 2 subparts. Because each of the 3 parts has 2 columns. Then the 2 columns is divided into 2 subparts. So which means each subpart would be 1 column. And then from each subpart to the next subpart, we need to switch value for the second condition. So we come up with yes, no, yes, no, yes, no. And then based on the information, we can come up with our initial version of the table. So for example, the first rule says if this L stands for lower range, so which means if the customer orders less than $500 and the customer pays using our charge card, then we give $20 coupon. Okay? The second rule says if the customer orders less than $500 and the customer doesn't use our charge card, then the customer would receive a $5 coupon, so on and so forth. And then we try to simplify our decision table. Initially, we have 6 different rules, and then we realize that the third rule and the fourth rule could be merged, because here again, they have the same action here, and also they share one condition, that is here order amount is medium, so that is the customer orders between $500 and $1,000. So in that case, it doesn't matter whether the customer pays using our charge card. So these two conditions could be merged. And finally, these two conditions could also be merged, because again here the action is the same, give 10% discount. On the other hand, the first condition is also the same, that is high, the customer orders $1,000 or more. So here we can come up with our final version of the decision table. So as you can see, the third rule says if the customer orders between $500 and $1,000, then the customer would receive 5% discount. On the other hand, this rule says if the customer orders $1,000 or more, then the customer would receive 10% discount. In this session, we learned how to use decision table to describe decision logics. And thank you for watching.